Hello, my name is Kostas. I work as the technical artist teacher at the Game Assembly in Malmö, Sweden. Now this video is a part of a larger series of videos called Getting Started with ShaderFX for Maya. And in this video I'm going to be talking about how to work with the linear workflow with ShaderFX. Now this is actually a larger topic in itself, and I'm not going to go in depth as to exactly what it means. It can be quite abstract. But I do want to mention that my favorite video for explaining this to people without going overboard is this one by Minute Physics called Computer Color is Broken. If you're not familiar with what I mean when I say gamma space and linear space and what impact that has and why there is such a concept to begin with, I truly recommend that you watch this video or find some other source which you find easy and graspable. So in terms of how you work with it in ShaderFX for Maya, I grabbed an image I'd snapped of a forest walk, I think, just as a showcase image, and I also added a free normal map I found online. Now, if you compare the texture here in Photoshop and you compare it in Maya, I'd say that they're kind of what I expect in terms of color representation here. This is kind of what I expect when I apply this texture here to a simple shader which has some Lambert lighting calculations and a normal map. Now, you wouldn't get this kind of result by default in Maya unless you change some settings here and you're aware of what you're doing. So if I jump into the ShaderFX shader I'm using, which is essentially just the base shader, which I go through in the video called bare minimum shader. So essentially this is just the core nodes you need to output color on the screen. I've got this group here called shader calculations, which is actually just the Lambertian lighting calculations, but you can imagine this being the scope of a full PBR shader, if you will, down to the most simple shader like this one. And on this side is my inputs that I'm inputting into this shader calculation group. Now, the way it's intended to be used is that all the textures coming in here or all the inputs should be in linear space when the calculations are done. So this is basically it. This is also the three areas I have in my ShaderFX shader. If you imagine these being the inputs, here are the shader calculations, and you could refer to this as outputting on screen. It's not entirely true, but I'm not doing any shader calculations at this point. I'm just wrapping up the shader, if you will. So the inputs can be in both gamma or linear space, depending on what type of texture you're inputting. The shader calculations should be done in linear space. And then lastly, as you output to screen, you want to make sure that you're in gamma space. So there's a way of converting between gamma to linear or linear to gamma space. There's math for doing this, and depending on what you mean when you say gamma, or if you're actually referring to sRGB or whatnot, the calculations will differ a bit. But to simplify, let's just refer to it as being a thing you can do, switching between gamma and linear. And Maya takes care of this for you. You don't have to do the calculations yourself. In fact, by default in Maya, as I'm in ShaderFX and I place the texture map node, it's set by default to read as a linear texture. And converting to gamma as the very last step is also enabled by default in Maya. The way that is enabled by default is actually this color, not sure what it's called, but it's transforming the color space live in the viewport. So by default, this is checked as on, and it says sRGB gamma. That is actually the part of Maya which is taking care of converting the results from our ShaderFX shader to gamma space. So we don't have to worry about that. That's already on by default. If you disable it, this will appear a lot darker. Or if you enable it and go to raw, you should still see the same kind of dark results. But I'll just leave it at sRGB. So back to what I mentioned, this is set to linear by default in Maya. So if I go in here and I show you, let's go for this one, for instance. By default, if I grab a texture map node, you can see that there's an option called convert to linear space. that is off by default. And since it's off, it's now set up as if it was already a linear space texture. If it's already linear space, I don't need to convert it to linear space. I'm already in linear space. But for this one, in order for it to show correctly, the color representation, I had to check convert to linear space. Since the logic is, and the way I think of it is, anytime when it's, say, a photograph, or say that it's a hand-painted color texture by an artist, essentially where someone has visually chosen a color representation because it seems aesthetically pleasing, that is a gamma space texture. When it's a texture which is more of a storing mathematical data, say a normal map, the normal map isn't painted because those colors and values are aesthetically pleasing. They actually represent mathematical values. In those cases, those textures are and should be treated as linear space textures. And things like AO, I would also likely consider linear space. Roughness, yes, likely. Metalness, etc., sure. But the way I think of it, there's no exact right and wrong answer to those kind of fuzzy textures that might be semi-aesthetically painted or generated. But I generally tend to only gamma correct the color textures in the way I work with them. Regardless, if I show you what this actually does, if I uncheck the convert to linear space on my color texture, I get this kind of bright result. And if you compare that bright result to this one, I'd describe it as this one being brighter and kind of washed out. And that's in terms of actually what this visually does. You don't, if this is set up correctly, you don't need to think of them as something visually happening. It just works on its own, right? But as you go from gamma to linear, it will darken the image, and as it goes from linear to gamma, it will brighten the image. And since I'm actually loading a gamma space texture, and I'm loading a gamma space texture, but I'm not properly converting it to linear. That means it's going to go in as gamma here as well, and then there's a second, or not second, then the gamma is being converted to gamma, if you will, which will make it overly bright. So I could, just to show you, if I leave this unchecked, so I have this overly bright, if I then disable this, I'm back to this kind of more correct, if you will, or same kind of punch and color as in Photoshop. But the difference is now I'm not at all handling converting here or converting here. So any kind of shader calculations I'm doing here, like lighting diffuse parts and specular and whatnot, will be done with the gamma space results, and those equations will actually not equate correctly as intended. So you should make sure that everything that happens in the shader calculation part is linear space. So to switch this back to functioning more properly, I need to enable this one. And notice how it's now overly dark, because I'm now going from gamma to linear, but I'm missing the last part. So when I'm viewing the linear results, it appears as darker. And if I enable this, I'm now back at correct color representation, and anything happening here is done in linear space. The normal map node luckily does not have this convert to linear space exposed here if you use it. It's already assuming, since the name of the node and it's intended to be used as a normal map, that it is linear space. So there's actually no need for you to have this checkbox here. This one, however, when you use a texture map, this could be anything from like a photograph, as in my case, or an ambient occlusion or roughness or whatnot. And depending on what's inside of it, you might want to check this or not. But it's something you should be aware of. In some of my videos, I might not put emphasis on actually setting this up correctly, and that might be because I'm showcasing something like getting a flipbook animation working. It's not actually getting correct value representation for color, but actually getting the motion of a flipbook working, for instance. So that should be it. I do not want to overcomplicate this topic. It's just something that you should be aware of to get the correct kind of color representation, and making sure that the shader calculations are getting the correct type of inputs.